Limiting resource usage by an application. Okay, so anything about this resource usage limitation, Manish, Ashish, Nagi?
Like we allocating limiting the CPU usage as well as memory to consume.
Yeah. Defining resource request and limits for pods. Now, what exactly a request is? Okay. Let's say you want to run a pod. Okay. And for that pod, you have mentioned your resource request is, and in that resource request, you have mentioned the memory as, let's say, 80 GB. Okay. Now, the scheduler will only schedule this pod on the worker node if the worker node is having the 80 GB of memory, total memory, not available. Okay. So that is something like a resource request. Now, let's say one worker node inside your cluster is having, let's say, 500 GB of RAM. Okay. So obviously the scheduler has a power that it can schedule this particular pod on this particular worker node. Why? Because this is satisfying the condition. This is having the memory more than 80 GB, right? But once this pod is scheduled on this worker node, how much resource it can consume over here? That is known as resource limit. Let's say memory 100 GI. So minimum 80 GB memory is required on the worker node for scheduling this pod, and once the pod has been scheduled on the worker node, it cannot exceed 100 GB. Clear? Clear, Manish, Ashish, Nagi?
That's fine.
Okay. So resource request used for scheduling and to indicate that a pod cannot run with less than the specified amount of compute resources. And the scheduler tries to find a node with sufficient compute resources to satisfy the pod request. Used to prevent a pod from using up all the compute resources from a node. The node that runs a pod configures the Linux kernel cgroup features to enforce the pod's resource limit. Okay. Now, how you can define this? So inside the specification of containers, okay. So in the dictionary of the containers, you need to define the resources section. In the resources section, you have two options. One is request, one is limit. You can like limit the resource request for the CPU and the memory, and you can also apply the resource limit for the CPU.
Kaushal, go to the your paint sheet. Why resource request should be higher, lesser than the resource limit? It should be equal or less than.
Why less than? Request is 80 GB, मतलब 80 GB किसी वर्कर नोड पे नहीं मिला तो ये pod schedule नहीं होगा. Once the pod has been scheduled, वहां पे ये 500 GB भी तो consume कर सकता है. So we have limited that to 100 GB. Clear?
Let's as a when we go with the AWS online as a public cloud requirement to host our application, right? So our demand is like that. I need a 10 GB, 64 GB RAM and 10 vCPUs, right? So these are type of requirement I have, right? As a application owner.
Mm-hmm.
So what is equivalent to that resource request? So my resource request is 64.
You are taking a wrong example, Manish.
Okay, sorry. Can you please?
Let's say this worker node is having 500 GB of RAM. This worker node is having 80 GB of RAM. This worker node is having, let's say, 60 GB of RAM. Okay. Now, let's say you want to run a Java application. Now, to launch the Java application, the minimum memory you required is 80 GB on a worker node. Okay.
Okay.
So that we have defined in the resource request. So what scheduler will do? Scheduler will try to find the worker node which is having the memory more than 80 GB, right?
Okay.
So the pod can be scheduled over here and over here, right?
Fine.
It will not be scheduled over here. Now,
Right.
let's say the pod has been scheduled on this worker node. Now, once the pod has been scheduled, okay, this particular pod can use 500 GB of RAM now.
Why it's okay? Okay.
आप लिनक्स पे कोई अगर जावा के एप्लीकेशन चलाओगे और लेट से आप PHP के एप्लीकेशन चला रहे हो, 500 GB रैम है, जावा अगर 500 GB कंज्यूम कर लेगा तो फिर PHP कैसे काम करेगा?
You understand, but we
have to limit that now. That the pod cannot use more than 100 GB on the worker node. Okay? Because we need to run the different pods also, no?
Okay. So basically the flavor is resource limit. The flavor values are coming in the resource limit section. Is that? You can say that?
Yes. Yes. The pod cannot
same-
exceed 100 GB of memory on the worker node.
Yes. Yes. Same example in VMware. Like hypervisor, we have 24 core, but we have allocated to VM on 8 cores. But लेकिन ने क्या VM ने क्या कंज्यूम 8 कोर ही नहीं करेगा था, लेकिन वो हाइपरवाइजर पे जितने रिसोर्स फ्री है वो भी यूज करता है कभी कभी अगर लोड जाता रहता है. ये
We always limit.
limiting.
No, my just confusion is that caution is that as a resource perspective, application resource requirement perspective, that is the resource limit is the actual parameter, right? From the application perspective, correct?
Yes. आपका application 100 GB से ज़्यादा use नहीं कर पाएगा.
Correct. So from better scheduling or other perspective, that is resource requirement. My confusion is that why the resource request is coming, because if I give the resource limit is equal to 100 gig, it automatically should reside on A only, first worker node only, correct?
No. If you are not giving the resource request, the scheduler has a power that it can schedule the pod on the 60 GB worker node also. Okay.
Why so? Because my requirement as a Java pod requirement is 100 GB. 100 GB is not available.
Yeah. So I'm saying now that if you are not defining the resource request and you have only defined the resource limit, it is possible that scheduler can schedule the pod on the 60 GB of worker node, right?
So, sorry, Kaushal, I'm again putting the question again. Just like in a normal virtualization or normal OpenStack cloud perspective or normal AWS VM, we are just creating a flavor that one VM is required 64 GB RAM and this amount of vCPU or this amount of storage, correct? And we are discussing about the RAM only, so that's why we are just I'm just taking example of 60 GB RAM, right? So my VM is reside on that particular worker node where the 64 GB is available, right?
Yes.
So I am saying that my resource limit is 100 gig RAM.
Yes.
So then why should it residing on 60 GB worker node?
Because the scheduler does not work with the resource limit. It always sees the resource request actually. The program is designed in a way.
Okay. So that the scheduler
will always see the resource request.
Okay, sorry.
It does not care about the resource limit.
Okay, now that is the answer. So the scheduler coding is like that. It should look into the resource request only. What is the resource request of that particular port? Correct?
Yeah, if that is 100 GB, it will only schedule the pod on the worker node which is having more than 100 GB.
So after that, it's see the limit part. That's okay. Yeah. I will limit it by that what are the value we are saying. So it should be
once the pod has created. Okay. Correct. So with the help of kubelet, some C group files are created to limit that pod. Okay, or to limit the resources consumed by the pod. Got it? That is not the work of the
schedule. Can you repeat this again? This C group again? I'm not get that part. Once the resource request is.
If we want to define a limit on an application, you always need to use a C group feature. Okay.
Okay.
Yeah. So the kubelet is responsible to create that C group. Okay.
Okay.
Yeah.
Okay, so normally it should be the same value. Resource request and the resource limit should be the same value, right? Normally.
Not the same value. You can put it 200 also, no? $100 तो मिनिमम चाहिए ना, और एक बार शेड्यूल हो गया तो वहां पे
understand, but as a actual production site, if my application is required required 100 minimum, and also limit should be 100. It should not be less than the resource limit. Never be less than the resource request. It should be higher or equal. Correct?
Yes.
Okay.
So you can define the request and the limits like this, like CPU, memory, CPU, memory. Okay. Now.
Why?
And yeah, one more thing.
What is MI?
Memory. Yes, megabyte. It is the Linux term actually. Okay. In Linux, you do not write GB, no, you write GIB. I think GB is equal to 1024 and GIB is equal to 1000. Yeah.
Okay.
Now.
Okay, so MB or MIB, is it?
Yes, MB or MIB. Both. MI is called the MIB byte. MB is called the megabyte. जैसे GB byte तो gigabyte ऐसे. Okay. Pronunciation is different. Otherwise, almost same. Now. So one thing you can do that you can directly edit the pod in YAML and you can write these things. Now, if you do not remember these things, then the OpenShift has given you the OC set command. What you need to set, we need to set the resources. So we have written the resources. Where you want to set the resources in deployment. What is the name of the deployment? This is the name of the deployment. What request you want to set on CPU and memory, and what limit you want to set on CPU and memory. Got it? So it is a very simple command to edit the deployment. If you do not remember how to write these things, clear? Now, viewing request limit and actual usage.
The same thing happened. I think I just seen that one of the document that last to last chapter we are setting the service account name, right? Chapter service account also, right? And we are just modifying through the OC set command. OC set and we can do it by OC edit deployment file as well, right?
Yes. But OC set is a non-interactive method, no? You do not need to remember the YAML. You can directly set the things.
So
and even you can take the help. OC set -- help or OC set resources -- help.
Right. This is the actual right way to do the configuration, right? By the command line.
Yes. Right. Now, using the OpenShift command line interface, cluster administrator can view compute usage information on individual nodes. So OC describe node 1, this. So it is describing the complete node, and see, you are seeing the request over here. 600 MB, memory is 1506 MB, limits and 502 MB. Clear? So with this particular command line interface also, you can see the information about the resource request or compute uses on an individual node. Okay. Yeah. The summary columns for request and limit display the sum totals of defined request and limits. Means, let's say you have created 3 pods on a worker node, and that 3 pods are having the CPU request as 10M, 20M, 30M. So total is what? 10 plus 20 plus 30 is 60. So it will show you over here 60M. Okay, like that. So it is a total of that. Now, you can also use OCADM top nodes command. Okay. What this command does, this particular command is very powerful. This command shows you the actual usage of CPU and the memory in the worker node on the OpenShift cluster. Why? Because as you know, in the OpenShift, Prometheus is already configured. And Prometheus is an intelligent tool which can gather the information about the CPU and the memory usage. Okay, real-time data. So if you are running this command every second, you will see that the output will be changed. Okay. 14 right now it is using 14%, 4%, 519 MB CPU, 167 M CPU. Memory is this. Okay. All the things it will show you. Now, And -L means you are giving a label over here, node role.kubernetes.io/worker. That's it. Now applying quotas. What exactly a quota is? Now quota is something like there are two types of quota: object counts, compute resources. Okay. Now object count is what? Let's say I have created a project for someone. Let's say Manish, I have created a project for you, right? Now tell me Manish, if you will log in on the cluster, how many pods you can create in this project?
As per my quota, whatever the quota is defined in what number of pods or
if
what
the
number
quota is not applied, then
I think by default I will
you can create
resource
multiple number
of
of
the
pods, right?
yes.
yes,
You can create
I think,
multiple number of secrets,
yes,
lot of things. Clear?
right. If the nothing
That's
limit,
why,
no limit is
yeah,
defined, then I can unlimited define definition as admin.
find object quota on the project. Okay. So in this particular project, you need to create a YAML file. Let's say I'm writing it as a manish.yaml, API version colon something, kind will be resource quota. Okay. Metadata, name something, name space Manish. So you have to create a resource quota object or API resource inside this project, and you will define in this object quota that pod can be maximum you can create as 10, secrets you can create as 3, okay, PVC you can create as 6, services you can create as 8, route you can create as 3, like that. Deployment you can create as 5, replication controller you can create as 7. Okay, so once this object quota has been created inside the project, when you will logging in that project, Manish, you will not be able to create 11 pods. Got it?
Absolutely.
Yeah. So that is the object count. And compute resources. Let's say I have defined a limit as memory as 50 MIB. Okay. So all these resources which are running in this project, they cannot exceed 50 MB of memory. Got it? So that is the compute resources. Now, imposing a quota on the number of Kubernetes resources improves the stability of the OpenShift control plane by avoiding unbounded growth of the etcd database. Quotas on Kubernetes resource also avoids exhausting other limited software resources such as IP addresses for IP services. Now, how you can deploy this? So pods, replication controllers, services, secrets, PVC, you can create the object quota of the PVC also. How many number of PVC can be created? Okay. CPU request, memory request, even storage request. Storage request means, let's say if I have applied the storage request as 10 GB, okay, on this particular project. So let's say you are creating over here 2 pods. So now you cannot create a PVC more than 10 GB because PVC is something like to request for the persistent volume. Okay. So if you have created 5 GB of PVC over here, and if you have created 5 GB of PVC over here, and now let's say for a pod, you still need some more storage. Then if you will try to create the PVC of 2 GB, it will not be created. Okay, why? Because you have requested 10 GB of storage from this project. You cannot request more than 10 GB. Got it?
And
so that's how you can apply the limit on the storage also.
You have mentioned the PVC request is 6, correct? PVC numbers in the left side.
5 GB, 5 GB.
It's 6.
No.
Yeah, ignore that. Ignore that.
So you
that
can
is the PVC maximum number.
Yeah, that is PVC number.
If I 3 PVCs. Okay, you cannot create more than 3 PVCs. Got it?
Right. Got it.
Yeah. But you have to manage the 10 GB in the 3 PVCs. You cannot request 10 GB more than 10 GB. Okay.
That is fine. That is fine.
Request.memory, request.cpu. How you can apply it? API version resource quota, metadata specification hard. Services, you can create not more than 10 services. Yeah, one more thing. Tell me one thing, guys.
What is services?
What you are saying, Manish?
Services part 10.
You don't know about service.
अरे यार दिमाग नहीं चल रहा.
Node port, external IP.
Okay. Services. Okay. Got it. Services.
Extra
got it. ठीक है. आ गया. याद आ गया.
Okay. Now.
Expose services right route. ठीक है. Got it.
Now, tell me, Ashish, are you there?
Yes. Yes.
Tell me, Ashish, let's say someone has created 3 pods over here. Once these 3 pods have created, after that, someone has applied the object quota on the pod as 10. Now, how many pods you can create in this project?
7. After that, 3
But
already
let's say
created.
someone, okay, you are telling 7. Okay, let's say someone has created 15 pods over here. And once the 15 pods are created, you have deployed the object quota as pod equal to 10. Now what will happen?
Nothing created. It's only running 15 pods.
Yeah, so it will not delete 15 pods. So if 3 pods are created, after that, if you're applying object quota, then how many pods will be created?
7.
But if 15 pods have been created and if you're running the quota as 10, so it will not delete 5 pods. Got it? Yeah. Now.
Why so? Why should be deleted, na?
No. It will not delete. Actually, if you are applying the object quota, okay, when some pods are already available in the project, so the object quota will never affect the existing resources. Got it?
Okay.
CPU 1300 M, memory 1.5 GB. How you can create it? OC create --save config -f dev quota.yaml. That's it. You can ignore this option. Okay, if you are not writing this option, that's okay. Okay, it is same as -f or without save config. OC create quota. Yeah, one more thing. If you do not want to create the quota like this, you can create the quota with the help of OC create quota command. OC create quota, dev quota, hard, services 10, CPU, memory. You can get the resource quota.
What is
compute quota?
Okay, just dev quota means name.
Yeah, name of the quota.
Okay,
this is the name of the quota.
Hard in the hardware. Okay, name is the dev quota. Okay, and the rest of the things in hard, all the things are coming.
Yes, services, CPU, memory, replication control, PVC.
You can also apply soft limit to the
what do you
quota.
think?
Soft limit to the quota.
No. Only hard limit, I think. Okay. Now, and there is nothing like soft limit actually. Okay, in the resource quota section, there is nothing like soft limit. It is always a hard limit. Okay. Because if you have defined the services equal to 10, you would not be able to create more than 10 services. So you cannot ignore that. Okay, once it is applied, it will be there. You would not be able to create more than 10 services. Okay. Now,
Okay.
OC get resource quota. So see what are the request pods. See 3 pods you can create, but 1 is active. 5 replication controllers you can create, but 1 is active. 2 services you can create, but 1 is active. Okay. How many CPUs being used? How many memories being used? Everything it is giving you. You can describe the quota. So name, in which namespace this quota has been created, how many pods have been used, what is the hard limit, okay, what are the resource used, and the hard limit. Hard limit is 10, but used is 500 M, 300 MI, 1 GB is the hard limit. It cannot exceed more than 1 GB. If you want to delete the resource quota, OC delete resource quota. Now applying limit ranges. Now see, a limit range resource, also called a limit, defines the default minimum and maximum values, okay, for compute resource request and the limits for a single pod or container defined inside the project. A resource request or limit for a pod is the sum of its containers. Now, let's understand this. The kind will be limit ranges, and see, right now in the limit section, you are defining a type as pod. In the pod, you are defining the maximum, how much CPU, how much memory the pod can use. Okay. So CPU is 500 M, memory is 750 MI. Now let's say this particular pod is having 3 containers. So those 3 containers could not exceed 500 MB. It is the sum of CPU request in all the containers of the pod. Clear? Now, it is also written over here. Pod is a sum of its containers. Now, minimum CPU is this, minimum memory is this. Means if your worker node is not having the 5 MB of memory, it would not be created over there. Clear? Type container. So for an individual container also you can define the maximum CPU, maximum memory, minimum CPU, minimum memory, and the default value, okay, as 100 and 100 MI. Are you getting it, guys? Limit ranges.
No, I'm not. This confusing me. Come again. What is the exactly use case of that minimum or maximum?
Maximum means all the containers inside the pod cannot exceed 500 MB memory. Okay.
This is the same limit we are setting on the quota level, right? Pod level.
Yeah, but actually if you want to set the limit for a pod, you need to write the information about resource request and limit in the pod YAML, na? But let's say you are having Manish 10 pods and you want to apply the resource quota on the 10 pods. Clear? Now how will you apply that? So for that we have the option as limit range. Got it?
Because in
see over here,
that limit, that kind is the resource quota, correct?
Yeah, right now we have defined the resource request and limits in the container section, na?
Container section, okay.
Now let's say if you are creating 15 deployments in a project, you need to write this 6 lines in every deployment file, right?
Can you show in some in the Kubernetes your lab? Just log in and just come. Is it possible?
Yeah, it is possible. Okay, just a second. Let's say you have created a namespace, kubectl create ns grass, okay, kubectl get ns vim resource.yaml. So in this resource quota, let's say we are applying the limits on the pod as 3, okay. Namespace is grass, kubectl create -f resource.yaml, kubectl get resource quota -n grass. It is created. One second. RESOURSC. Yeah, it is created. Now, right now there is no pod. Clear? Now, kubectl create deployment -image. Deployment name is Manish. -image is equal to nginx -n grass. Created kubectl get all -n grass. Now kubectl scale replicas, or let's say kubectl scale deployment Manish hyphen replicas equal to 5 hyphen and grass. Okay. Now see the pods. You have requested for 5 pods, but only 3 have created. Why 3 are created? Because we have applied the resource quota. Got it?
So this is basically what we're discussing, the quota part, right? That we are testing now. You have demonstrated, right? Okay.
Yes.
So
Now let me apply the CPU and the memory limit on this.
Correct. That should be on the container level, right?
Yes. Why it is not deleted? The deployment.yaml.
Yes.
Replica 1.
Yes, in the container section, we have to. We can add it below, right? Okay. Resources.
Now let's say I'm giving a memory limit as 80 GB. Okay. Now kubectl create -f deploy.yaml. Request CPU memory. It is request and s. Okay, it is s. Created. Now see kubectl get all -n grass. It is in the pending state.
Correct.
Why it is in the pending state? Because it is not finding any worker node which is having more than 80 GB. You can also see the events. 0 to 3 nodes are available. Insufficient memory, right?
Fine. Got it.
kubectl delete.
Okay. Just hold. Go to that particular YAML and limit it into 10 GB or 1 GB. This is requested now. Okay, it should be higher, not less than. Okay, just hold on. Can you change it to 1 gig and the memory is 2 gig? Limit is 2 gig and the memory is 1 gig. 2 gig उसको 1 कर दो. 1 gig तो होगी ना यहाँ पे, है ना, right?
Yes. But how we will like make the load on the application? How we will check that it cannot exceed more than 2 GB?
We can go to that particular compute where that pod reside and describe that about what requested and what is using, right?
Yeah. kubectl get all -n grass. It is created.
Okay.
Now kubectl. It is created on node 1. kubectl describe.
Can you first see the events, then we will find that where that resides. Okay, this is node1 kushal.com, na? Maybe
yes, kubectl describe node1.kushal.com and see. These are the total request. Okay, 2 GB is the limit, right?
2 GB is the limit and requested is 1, correct?
Yes.
1, 2, 2, 4.
Now let me delete that pod. Delete that deployment. Now see. Maybe the node 1 is having some other pod which is making this request.
No,
it is 0.
Yes.
Now it is 200 MB only. Okay.
I think some 200 will be taking by the default, whatever the mandatory pods, right? Maybe.
Yeah.
That is the.
Yeah. Even you can write it here 5 GB.
Okay, that's why it's showing the 1, 2, 2, 4, 4, 1, 5, 1.
Yes.
Okay.
Yes. So this was the example of this resource limit and the request.
And this
Limit ranges in Kubernetes. Let me take the YAML from here. See. Enforce minimum and maximum compute resource usage per pod or container in a namespace. Got it? Enforce minimum or maximum storage request per persistent volume claim in a namespace. Okay. Now, set default request limit for compute resources in a namespace and automatically inject them to containers at runtime. Now, enabling limit ranges. Now, they have not given any example over here. Configure. Okay, let me do one thing. Yeah. We can copy this. Vim limit range dot YAML, I paste. Where I want to create this limit range, namespace is grass. Limit says maximum is CPU, minimum CPU, type is container. Okay. So for container, let's say I'm applying a memory. Memory is 0.5 GI and minimum memory is 0.2 GI. Okay, let me apply it as 2 or 3. Okay, I think, okay, let me apply 3 or 4. Now, let me check if I have something in this namespace. I have nothing. Now I am creating this limit range. kubectl describe limit range hyphen and grass. So the minimum memory, maximum memory, and this is. Now let me create a pod. Vim pod.yaml. kubectl create hyphen f pod.yaml kubectl get all hyphen n grass hyphen o white. It is in the pending state. Why it is in the pending state, guys? We do not have applied any limit over here.
एक मिनट इवेंट में देखते हैं क्या आ रहा है.
Insufficient memory आएगा. Okay.
नहीं एक मिनट हमने pod level पे we are not applied any limit range, right?
For the container level we have applied now. To run a container inside a namespace, you will be needing minimum 3 GB of memory on that worker node.
नहीं मुझे कंफ्यूज हो रहा है, नहीं चल रहा दिमाग.
Negi, Ashish, are you clear?
Yeah, minimum 3 GB, max 4 GB.
Yeah.
let
me tell you, Manish, देखो सुनो. एक project है Manish, you have a project, okay?
Right.
If you are creating a deployment in that project, और अगर आपने यहाँ पे resource request और limit लगा दी, that would be applied on the project or on the pod level, right?
अगर मैं deployment में अपने resource दे रहा हूँ, then it will be applicable for the
only the pods which are created by that deployment, right?
Pod creating by that deployment, yes, only for that particular deployment only.
अब अगर आपके प्रोजेक्ट में ऐसे 3 डिप्लॉयमेंट है, लेट्स से यू हैव 3 डिप्लॉयमेंट्स और एक में ही आपने अप्लाई किया, बाकी 2 पे तो अप्लाई होगा ही नहीं.
नहीं, should be applicable of that particular deployment only. If it belongs to Nginx, then it's Nginx.
Now you want to apply the limit per pod कि मेरे प्रोजेक्ट में कोई भी pod या कोई भी कंटेनर क्रिएट हो जाए. ये मिनिमम रिक्वायरमेंट है कंटेनर के लिए.
So you are saying that in my pod we have multiple containers. So and we are limiting the minimum and maximum value for that container, creating the container in particular pod. Is it?
Yes. ओके, और यहाँ भी ये चेक करेगा कि अगर किसी नोड पे 3 GB मेमोरी नहीं है तो ये कंटेनर क्रिएट ही नहीं होगा.
ओके
ओके, बट ये सबके लिए एप्लीकेबल होता है. ऑल द कंटेनर्स और द पॉड्स इनसाइड योर प्रोजेक्ट, पर पॉड पे अप्लाई होता है ये ऑटोमेटिकली.
तो ये
तो आपकी एक टेंशन हट गई ना, आपको हर एक डिप्लॉयमेंट में वो चीज डिफाइन करने की जरूरत नहीं है ना.
So it will be applicable to for the full project because we are giving the namespace as a namespace here, correct?
Yes. Full project it will be applied for.
So
Now
why
आप per pod भी दे सकते हो.
in production we are using this? Is it?
Yes, limit range is a very cool thing.
Why?
But we do not prefer like कि हम लोग एक common limits लगाएं सब पे. हम अलग-अलग applications पे अलग-अलग limits.
That should be sensible. It should be imply on the pod level now rather than in the container level.
Yes.
Right. This is not a recommended way. Yes, this is the feature additionally given by the Kubernetes. But
yeah, maybe if you have a use case that you want to apply the same minimum and maximum use or request on all the pods inside a namespace, then you can use limit range. Okay.
Then I use the limit range.
Yes.
Okay. So that okay. If I want to apply this limit range on the pod level only, see these first 3 lines are applicable.
Fully defined pod.
Yes.
Do not define container.
Correct. So now it's clear now. So now that container is not required in that case.
Yeah. Default request. Okay.
Just on just go up. First part is related to the pod, then container. What is this default?
If for some container, if you have not defined any maximum or minimum thing, then default will be taken. Okay. Default means
same thing will default value will be applicable in pod section as well. We can define that as well, right?
Yes. You can define this default in the pod section also. Okay. Now, and default request 20M, 20 MI.
Let's example. I have in my project only 2 type of pod will be there, correct?
Yes.
So can I set the limit range on that my second number pod only?
No. Limit range always applies on all the pods on the namespace. Okay.
That's why I'm saying
if you want to apply for a single pod, you can use this, no? You can use this.
I can use the deployment one, first one, right? Upper one.
Yes.
This one.
Yes.
Deployment one. If I want to apply this limit on the deployment level or particular.
No. Limit range will be always applied on overall project basis. Okay.
Sorry, I'm saying that if I want to apply on the pod level, then I go with the upper one limit on the resources level on the particular deployment in the container section. Correct?
Yes.
That will be applicable only for the particular pods, right?
Pod, which is created by the deployment.
Right? So if I want to put the limit range on the overall project level or pod level or container level, right?
Then you can apply limit range.
Okay. So what is that type OpenShift IO image and what is that?
OpenShift IO image maximum storage 1 GB means you cannot use an image which is higher than 1 GB. Okay, inside a project. Clear?
Why? Okay, this is the type is just like saying about the parameter related to the image.
Image section. Okay, maximum storage is 1 GB. You have the image stream also over here. That is a very different topic. Okay. You have the persistent volume claim. A lot of things are there.
That is fine. PVC, right? That is PVC. Whatever we are putting the limit on the PVC level, right?
See, we have applied the minimum limit as 1 GB and maximum as 50 GB. What does it mean?
So minimum, I can apply PVC
for 1 GB. You
minimum
cannot apply below than 1 GB.
1 GB, correct. And maximum of the 1 gig, 50 gig.
Let's say you need 5 PVCs of 10 GB, then you can create. But once it is created, you cannot create another PVC. Okay.
Okay, so okay, what is that?
It is also written over here, number 7.
Understand that
That
fine.
is
That
the
is clearly
maximum image size that can be pushed to internal registry. Got it?
maximum image size. Okay. What is the image stream? The maximum number of image tags and the version
And versions that an image stream resource can reference. Okay.
Okay. जैसे Nginx का latest tags होता है, right? Something like that.
Yeah, like the way in the Docker Hub you can push the image with the multiple tags, no?
Right. Absolutely.
But in the image stream you cannot push the image which is having more than 10 tags. Okay.
Okay. Okay. If not more than 10 tags.
Yeah.
जैसे मेरे
Like
just
you do, na? CentOS colon latest,
right.
CentOS colon V1, CentOS colon V2. You cannot apply more than 10 tags. Got it? Because OpenShift is not using the Docker Hub, na? It is using the internal OpenShift registry, na?
Understand. My point is that let's if I selected the image is CentOS.latest, correct?
Yes.
Is that parameter is applicable on that part?
Yes. Latest is also applicable. Latest would be counted in one tag.
One tag, na?
Yes.
Sorry.
And total images you can store not more than 20.
Sorry, can you थोड़ा इसको और explain करोगे कि ये limit लगाने का how it relevant to the image stream? थोड़ा समझ नहीं आया ये वाला part.
नहीं, tell me Manish, this is Docker Hub. Okay.
If my limit is 2 or 3, 2 minimum, 3 maximum, how it impact?
No, let's say this is Docker Hub. Okay.
Correct.
Now, how many images you can store over here?
Max, unlimited with the versions.
Unlimited. And how many tags you can apply it on a single image? Let's say this such an image is having the V1 tag. You can apply a lot of tags over here.
Right. So I will.
But in the OpenShift, you are not using this hub.docker.com now. You are using the internal OpenShift registry.
Okay.
So on that, because whenever you create any image, that is always pushed to the internal OpenShift registry.
Okay. When I'm creating an image, we're going to the okay. So we are applying the versions on we are applying the tags on that. Okay.
Yes. So that's why you cannot create the same image with more than 10 tags. Okay.
Okay. So I cannot
store more than 20 images.
Okay. So I can use the we can say that manage the versions up to minimum 10 and maximum up to 20.
Not maximum 20. It is image tags and it is images.
Okay. 20 images and with the tag is maximum 10.
Means one image with 10 tags. 20 images with each 10 tags.
Okay. Got it. जैसे एग्जांपल में सॉरी मैं थोड़ा सा नहीं कि एक मैं हिंदी में क्वेश्चन पूछूंगा. मैं एग्जांपल कौशल एक ऐसा हुआ, इसका यूज केस ये हुआ, एक मेरी एप्लीकेशन चल रही है अपाचे की, राइट? उसमें मेरा एक नया कोड आया, करेक्ट? तो कुछ मैंने चलते मेरी एप्लीकेशन में कुछ मैंने एक नया PHP जो भी एग्जांपल एक फाइल अपडेट करनी है, उसको अपडेट किया, उसकी नया वर्जन एक फाइल बना दी मैंने इमेज की, करेक्ट? एंड रेस्ट आई डिप्लॉयड द मल्टीपल पॉड्स, करेक्ट? मेरा एक नया वर्जन बन गया V2, राइट? और मैं ऐसे 10 बार कर सकता हूँ और 10वें बाद मैं नहीं कर सकता.
Yes.
This is the use.
Can you speak in English?
That's why I said sorry, Negi. Just give me. I will re-explain again. Just Kaushal.
Negi, he is saying that if he is creating an image with the same name, okay, so he cannot apply more than 10 tags, okay, on the image.
Okay.
Clear, Manish?
नहीं मेरा अभी आंसर नहीं आया, सॉरी कौशल, मैं वही बोल रहा हूँ कि
No, you are saying right. If
I'm
you
saying
are
right,
creating a PHP image, you cannot use more than 10 tags on that.
ओके गॉट इट, ठीक है जी, उसका यूज के समझ आ गया, थैंक यू।
Yes. Now, even you can describe the limit range. So it will tell you the complete information over here. You can delete it. Now, applying quotas to multiple projects. Now, this feature is not available in Kubernetes actually. Let's say you have 15 projects inside your cluster. And those 15 projects are having the label as environment column there. And you want to apply the quota on the 15 projects in a single command. Then you can use cluster resource quota. Okay. How you will use that? OC create cluster quota, user QA, project annotation selector. You need to give the label over here. Environment equal to QA. Hard limit pods 12, secret 20. Got it? So it will be applied on all the projects which is having the label as this. Got it, guys?
Got it. So, okay, so that will be a specific addition feature given
Applied
by
on
the
15 projects in once, which is having the label as this. Otherwise, you need to apply it on the individual na, again and again.
That is fine. I think so. In production level, this is the very less use. Normally, as a normal user,
apply the same quota on the multiple projects together.
Correct. So that is very hardly used. This
Delete the cluster quota. See, to avoid large logging overhead, it is not recommended to have a single cluster resource quota. Got it? Over the 100. Now, customizing the default project template. Okay. Now see, cluster administrator can customize the default project template. Means additional resources such as quota, limit ranges, network policies are created when a user creates a new project. What does it mean? Let me tell you. Let's say you have created a template. In that template, you have defined a limit range. You have defined the resource quota and a lot of things. Okay, etc. Now let's say you want to apply this particular limit range and resource quota on a Manish project. Then what you can use? You can attach this template to this Manish project. Okay, so whenever a user will create the Manish project, the user will always run a command in a way that that command will attach this template to the Manish project. So this template is having the limit range and the resource quota that will be automatically created in this project. Okay, now let's say I have to create a Sachin project. In that also I need to use the limit range and resource quota. Then I can also again attach this particular template to Sachin project. Again and again, I do not need to create limit range and resource quota. Once I have created, I can attach that template to any project inside my cluster. So OC ADM create bootstrap project template. This is the command to create a template. OYAML and temp project template.yaml.
ADM create bootstrap project is the command name, is it?
Yeah, it is the command actually. Okay, complete command.
Dash create bootstrap project template full command, then referring to the YAML and attach the YAML file.
Saving it to template.yaml. Okay. Once this template is created, now you can edit the template. Kind template, creation time, name, in which what is the name of this, and objects. Now first object is project. Okay. And second is role binding. Third is resource quota. Okay. Fourth is, and these are the parameters. Okay. Project name, project display name, all the things you can give over here. Okay. Now, once this template have been created, you have defined the role binding, you have defined the project information where you want to attach this template, you have defined the resource quota, you have defined the project name, project display name. Now, description, admin user, requesting user, after that you can create it. OC create -f temp project template.yaml -n OpenShift -config. Once this template is created, now see, in the project, you are defining in the specification as project request template name project request. Automatically, let's say the project name is cluster. So in the cluster project, you are fetching the resources from the template and the name of the template is project request. So inside the cluster project, this particular resource quota will be created, role binding will be created. Got it?
This is a very useful feature for the production perspective. While you creating
Yes,
that,
this is a very useful feature. एक बार template बना के रख दिया, फिर जिस project में template call करना है करते जाओ.
correct. So updating with the name different YAML file according to the project, and just apply
Yes.
it while creating the project.
Yes. Now, guided exercise. Logging with the developer. Going inside a new project. Creating a deployment named as hello limit. Image we are using as this. Dry run client OYAML. We are saving the YAML. Now we are opening the YAML with vim command and we are
Setting
defining the resource request and memory.
in the
Okay.
deployment container section, right? In the deployment
Yes.
file container section.
Container. Now you are creating the resource and now see get ports. It is in the pending state. Why? Because we have defined the CPU as 3. Now no worker node inside your cluster is having 3 CPUs.
So we can see in the events, right? In the logs part, sorry. OC
Yes.
logs. Okay.
See insufficient CPU.
Okay.
Now change the CPU from 3 to 1.5. Okay. And now apply it. It is in the running state. Got it? Now scale it to 4 replicas.
In CPU, why we call as a 1.5 or 1 cent? Why is one?
Because my worker node is having 1.5 M CPU.
कभी सुना नहीं है 1.5 in decimal मतलब in points. First time सुना हूँ यार.
2 M मान लो. 2 CPUs.
Okay.
Okay.
वो चल मैक्सिमम मेगाहर्ट्ज में रहता है सीपीयू.
क्या कह रहे हो?
मेगाहर्ट्ज तो स्पीड पे डिपेंड करता है ना. Speed.
Yes, yes. M is, I think, one CPU is 1000 M. Okay.
Okay. One
for megahertz.
1000 M.
Yes.
Yeah, one CPU is equivalent to the 1000 M.
No, नहीं कुशल. वो सीपीयू एक सीपीयू ने क्या वो लिमिट रहता है, कोई कहने का 2.6 का भी रहता है मेगाहर्ट्ज का या गीगाहर्ट्ज का रहता है. 2.6 गीगाहर्ट्ज का रहता है तो उसमें से ने क्या 1500 ने क्या मेगाहर्ट्ज ने क्या उसको अलोकेट किया है. वो है उसका रेट. It's not.
No, it is one CPU is the same as core 1000 M millicores. Equal to one CPU.
Okay. One CPU is equal to 100 millicores. Okay.
Yes, one core is equal to 100 M millicores. One core is equal to one CPU, no?
Okay. Okay. Just hold on. So this is a physical CPU or is it just a virtual CPU?
No, physical CPU. अगर आपकी virtual 4 core है, 4 अगर आपके पास quad core system है, तो you have 4 cores ना, तो 4000 M CPU.
No. If there is one feature called hyperthreading in the.
No idea about hyperthreading.
नहीं कुशल वो एक ही सॉकेट एक ही फिजिकल सीपीयू रहता है लेकिन उसके नीचे 4 कोर रहते हैं, वो 4 थ्रेड रहते हैं.
हाँ सर. Why it is written as one CPU is equal? Oh, it is one AWS virtual CPU.
क्या आपका लैपटॉप पे आप देखोगे तो आपके लैपटॉप में ओनली सिंगल वन सीपीयू है और लेकिन वहां पर आपके नीचे थ्रेड ने क्या 4 है. थ्रेड 4 या 8.
MS Info 32 where this I have always a confusion in this section. Where is the CPU?
आपने तो डिवाइस मैनेजर में जाओ, राइट क्लिक करके
Intel Core i5-7200U CPU 2 core.
2 कोर्स है और
लॉजिकल प्रोसेसर.
2 लॉजिकल सीपीयू पर कोर है. यानी कि आपका एक ही सीपीयू है, फिजिकल एक ही है. आपका जो सॉकेट में लैपटॉप में एक ही सीपीयू है, उसके 2 कोर बनाए हैं और 4 लॉजिकल सीपीयू.
ओके, सो मींस आई एम हैविंग 2000 M, राइट?
यस, करेक्ट.
ओके, गॉट इट.
So if my requirement is as any of a normal user or a normal application owner, I need a 400 vCPUs. So I will give the 400 M, correct? 4000 M.
Yes, 4000 M. Yeah.
Okay.
Now 1500 M. And yeah, you are right. We cannot have two 1.5 cores. Okay, either it will be 1 or 2. Got it?
Right.
Yeah. So it will be always in the power of 2, na? 2 to the power 0 is 1, 2, 4, 8, 16, 32, right?
Yes.
Now, OC get pods, it is running. Now, now we are scaling the replicas to 4, okay, in the deployment. Now see, only 2 pods are running. Why 2 pods are not running, guys?
We need to see the logs first.
No, one
No,
pod
few limits.
requires minimum 1500 M CPU. Now 4 pods require 6000 M CPUs.
Correct. So we
And
have
you do
only
not.
3000.
Yes, we
3000.
only have 3000. We only have 4000 actually. 2000 on one and 2000 on one. So once if a pod is created on a worker node, the another pod will not be created. Now, OC get event C 3 insufficient CPUs. You can delete the pods. Now, deploy a second application to test memory usage. Okay. This second application sets a memory limit of 200 MB per container. Okay, Manish, this is your example.
Deploy a second application on a test
Test the
memory.
memory users. We are limiting the memory 200 MB per container.
And that second application set a memory limit on the 200 MB per container. Okay.
So we have
So
created a load test.yaml.
load set
Okay.
XML. Okay.
Deployment has been created. Now we are having the routes. Got it? Now on the routes, once on a one terminal, we are running the watch command, OCADM top pod, to continuously monitor the CPU and the memory usage of each pod. And now on the another terminal, we are making a curl request, okay, on this particular URL. And the pods is running, and now you are checking the memory over here. It is using 20 MB. Now it is using 172 MB. Now it is again using 20 MB. Okay. And now you are curling it. It is not giving you a response because memory exceeded. So the container will be closed. Okay. Now, see, it is killed. Status now. Again, in some cases, the pod might have restarted and changed to status of running before you have time to switch to the second terminal window. The restart count will have incremented from 0 to 1.
Sorry, this is not clear, Kaushal. Come.
यहाँ पे आपने लिमिट लगा दी 200 MB और 200 MB से जैसे ही ऊपर गया कंटेनर क्या हो गया आपका क्लोज हो गया, राइट?
Okay.
Because the pod is of out of memory, na?
Okay.
Out of memory.
That needs to be killed or restarted.
Okay. It should be restarted, right?
Yeah. Now it is running. And see, now it is not using any memory. Delete all. Now we are using with the admin user. Now we are applying a quota. We have already seen the practical in the Kubernetes, guys. Okay. So we are applying the limit on the quota 3 CPUs, 1 GB, 3 configuration maps. So that's very simple. OC create quota, project quota, hard, CPU 3, memory 1 GB, config map 3, and in the project schedule limit, we are creating it. Now we are logging with the developer user. Now see how many config map we can create in the schedule limit, guys. Ashish, not more than 3.
Yes, not more than.
Now we are creating the config map. How many? 4?
4.
So
Yes.
3 have created, 4th is not created. Got it?
Yes.
Logging with the admin user. Now again, you are creating a template. Okay. In the template, you are defining the resource quota, limit range, parameters. Now you are creating it with the YAML in the OpenShift config project. Now you are editing the project, which is named as cluster, and you are defining in the specification section, project request template, project request. This particular project request is the name of the template which we have created. Okay. Now, and after that, watch OC get pods hyphen and OpenShift API server. The pods are running and running straight. OC new project template test. OC get resource quotas, limit ranges. We can see the limit ranges and quotas. And deleting the project, both the projects over here. That's it. Now, we can do this section later, scaling an application. Or we can do it today also. I think we can do this today. Okay, very simple. Scaling an application. Now, tell me, Nagy, what do you mean by manual scaling and automatic scaling?
Manual scaling, we need to improve through the manual. I mean to improve the CPUs, increase the CPUs. Automatic, like in template itself, we can runtime itself, we can trigger, right?
Okay, Manish, you tell me about these two things.
So manual scaling means, so I want to scale the pod by just changing the deployment number or replica number. So this is a manual scaling. So automatic scaling is if my pod is reaching the particular number, that number of CPU usage or number of memory. So that pod should be scaled automatically, and it should be scale in. So this is the automatic scaling on the basis of the CPU, on the basis of the RAM.
Okay. Now, OpenShift does not provide the auto scaling on the basis of memory right now. Okay. This feature can be available in OpenShift 5 or 6 versions. Got it, guys? Now, you have created a deployment with replicas 1. If you want to scale it, you can give here OC scale hyphen replicas 5 deployment scale. Are you clear with this command? We have used this command so many times. Got it?
Either we go with the VI or run this command, right? By the scale changing the replica numbers.
Yes.
In the deployment file.
Now auto scaling. In the auto scaling, actually OpenShift is providing you a feature of horizontal pod scaler. Okay. So you need to use the auto scale command. OC auto scale. Or deployment name is hello. Minimum is 1 and maximum is 10 and CPU percent is 80. Now, can you tell me guys, what do you mean by these three options? Anyone?
So it means the DC, the deployment file called hello, it should be minimum, iska count, the pod count should be minimum 1 and maximum up to 10. When the CPU percentage will be 80, whatever the it should be up and down, a scale in, scale out happen.
Yes. So this particular command will automatically create a horizontal pod scaler. OC get HPA, horizontal pod scaler. Hello, deployment config, hello. 80% minimum is 1, maximum is 10. And right now, how many replicas is available? Only 1. Okay. Now, the horizontal pod autoscaler initially has a value of unknown in the targets. It might take up to 5 minutes before unknown changes to display a percentage for the current users. Okay. Because obviously the deployment config needs to contact the API server. API server will contact the Prometheus. Prometheus will give the actual real-time data about the CPU being used by the pod. Got it? Or application. So it can take up to 5 minutes. Now, there is a guided exercise. Logging with the developer user, going inside a new project, opening a file load test.yaml, and in that file we are defining a resource. Request is this and the limit is this, guys. Okay, now see, what is the limit? Limit is 100 MB and memory is 100 MI. So obvious we cannot like auto scale on the basis of memory. That feature is not available. Only the feature which is available, which is CPU, auto scaling on the basis of CPU. So OC create save config, we have created it. Now OC get pod, it is in the running state. How many limit we have applied, guys, over here on the CPU? 100 M. Now
Yes.
we are describing the pod, the CPU is 100 M. Now we are trying to scale the replicas to 5. Okay. Now 5 the pods are running over here. We are scaling the replicas to 1. This is the manual scaling. That is okay. Now we are trying to create a horizontal pod autoscaler. Create a horizontal pod autoscaler that ensures that load test application always has 2 application pods running. So we have to give a minimum value as 2. And that number can be increased to maximum of 10 pods when CPU load exceeds 50%. 50. How many CPU we have given over here? 100 M. Okay. Now we are trying to get the HPA. So right now the CPU is being used as 0% and the limit is 50 and 2 replicas is there. Now we will try to get the route and we will try to make a load, generate a load on this particular application. And now see, at the moment you are generating some load, see, automatically the memory is used, the CPU has been used as 172%. So the replicas has been increased to 9. Okay. And now, got it, guys? Now create a new application with the OC new app command. Again, create a second application named scaling that uses a deployment configuration resource. Scale the application and verify the response coming from the application parts. So we are creating a new app, name is scaling as deployment config. Image we are using as scaling, version is v1.0. Everything is created. Now we will expose the service, so the route will be created. Now we are trying to scale this application to number 3, replicas is equal to 3, and we are trying to get the pod. So 3 replicas are running over here. These are the IP addresses. Now we are trying to get the route and we are trying to access the application. Okay. So this particular script will actually make several requests to the application. On this IP address 34, on this IP address 34, on this IP address 32. Now, OC get HPA, right now it is on the 50%. Delete the project. Okay, just a second. Yeah, we are not generating any load actually. We are just curling the pods, okay? And that PHP application is giving the response. So that's why the load is not increased. It is still 2. OC delete and lab finish. This lab you need to do, guys. Final lab.
Done ji. I think आज काफी पढ़ा.
Chapter 7th. Tomorrow or today?
बिल्कुल tomorrow यार, not today.
Tomorrow. Correct.
And now OpenShift do not have nothing. 7th chapter is a very simple how you can update the cluster, and the 8th chapter is all about the web console actually. With web console.
Okay. Done, Ajit.
Okay, guys, that's it for today then.
Stop the recording. Thank you.